The purpose of this section is to familiarize you with energy and its different forms. Let's start with the definition of energy. Energy is defined as the ability to do work. There are many different forms of energy that you may be familiar with. There is electrical energy, which can be in the form of lightning, thermal energy, fluid energy, like water rushing through the dam, chemical energy, which can be found in a battery, atomic energy, like in a nuclear power plant, sound energy, and mechanical energy, or the energy of motion. Right now, we are going to focus on mechanical energy. First, we are going to look at internal potential energy, or simply potential energy, which is a form of mechanical energy. Internal potential energy is determined by the nature or the condition of the body. Potential energy is named as such because of its position or internal characteristics, not its motion. Some examples of potential energy would be gasoline. When you burn gasoline, internal potential energy is released in the form of combustion. A compressed spring also has potential energy. If you decompress the spring, all of the potential energy is released. This is why coil springs and springs on struts on vehicles are so dangerous. There is a lot of potential energy waiting to be released. One last example of potential energy is the chemical potential energy of the battery when the engine and ignition on your car is turned off. Another type of potential energy that we will be doing calculations with is gravitational potential energy. Gravitational potential energy is the potential energy that is determined by the height of an object above a reference level. When we are using our formula for potential energy, we are referring to gravitational potential energy. Potential energy is equal to the object's weight multiplied by the height above the reference level. As a reminder, in the last unit we learned that the weight of an object is equal to its mass multiplied by the acceleration due to gravity, or g. Our units for potential energy will be foot-pounds, which should also look familiar since our units for work were also foot-pounds in the English system. Weight is measured in pounds, and height will be feet. In the metric system, potential energy is measured in joules, weight is measured in newtons, and height is measured in meters. Let's take a look at one example involving potential energy. A girder weighing 5,570 pounds is at the top of a building. It has a potential energy of 517,000 foot-pounds relative to the ground. We want to know, how high is the girder? First, let's take a look at our equation circle. We are solving for height, so when we cover up height, we see that we are left with potential energy divided by weight. Our potential energy is 517,000 foot-pounds, and the weight is 5,570 pounds. Therefore, the height of the girder above the ground is 92.8 feet. In the next video, we will take a look at another type of energy, kinetic energy.